is going to be Monday over the second half of chapter 1. The study guide is loaded. The homework assignments are loaded associated with that study guide. I will say that if you're comfortable with my study guide, you should be okay for the exam. All I plan on doing is going through the assignments given and creating a multiple choice based off. I just plan on doing a little differently instead of forcing the multiple choice from my math lab. Okay. Now let's answer questions. Actually, that's it. You don't want to do it. You don't want to stream it. Yeah, so the grade book. Your midterm grade is only going to be based on exam 1. That's the only grade that I have. It's not live, so whatever grade, it's really only based on exam 1 grade. Because exam 2 is going to be Monday, and I think we have to submit midterms grades before that. So it's only based on what you got on exam 1. So, but that doesn't really mean anything. That's why I don't really like this whole system, because it doesn't mean anything. It doesn't mean anything. No, what I'm saying is, again, you're reading way too deep in it. It's exam 1. We're going to take at least 2 more exams and a final. That's what I mean. Anything can happen. You could have got a 0 on that exam and still get an A in my class. That's what I mean by it doesn't really mean anything. So don't read too much into it. I would have liked to have gotten the second exam in before that. It just didn't work out that way. You know what I'm saying? So we can kind of offset some of that stuff. Okay. Other questions, comments, or concerns? All right. Okay. I did not check to see if it's working properly. I'm going to go ahead and open this. I know that that label is wrong. I just didn't have time to kind of set that straight. I have to change it later. Okay, ladies. So my only request for my course, you got to keep the distractions to a minimum. So that means the chatter, you got to keep it to a minimum. I don't really mind if you want to communicate with your neighbor. I don't mind if you text each other. But if you make sounds and things, I'm going to pause. It's going to disrupt my flow and rhythm. If you distract me, it's going to waste everybody's what? Time. If we're wasting everybody's time, we're wasting everybody's money. So out of courtesy for yourself and your classmates and everybody, got to keep the distractions to a minimum. Again, I don't mind if you text each other. Just make sure your phones are on silent. I won't make a big deal about that. But if I'm listening, because I can hear you guys like very, very vividly. Okay. So please just text each other, or you can write it on your paper, something where I can't hear it because I'm listening. Okay. I'm assuming that this is working because I don't hear anything. Yeah, it's working. Okay. Turn this down. I'm going to let that be. All right. So today we're continuing with chapter 1. Last time we did 1.5. So, we're going to keep moving. I didn't stream 1.5. If anybody needs me to stream 1.5, I can. It was really just a couple of examples, but we're just going to keep moving forward. So in section 1.6 today, we're looking at other types of equations and applications. So we have rational equations, work rate problems. This is going to take us a little while. It's a little intensive. Okay, we'll do a few examples. I'm not going to be able to go through all examples, so I am going to leave some as an exercise. You want to be sure to go through each example and make sure, take the original and work it like you're in an exam, and then just make sure that you can get those results. Okay, so don't just assume that you know it. A rational equation is an equation that has a rational expression for one or more terms. To solve a rational equation, multiply each side by the LCD. Okay? So just like before when we were getting rid of fractions, we multiply the left and right side of the equal sign by the LCD. We're going to use the same technique here to get rid of the fractions. Okay? Let's see. I didn't really want to see the solution. Okay. So now, this is not that trivial. What's the LCD of the denominators? I heard 3x minus 1. That's right, provided your interpretation. Okay, what's the denominator that's on the far left? Yeah, that is right. So 3. I was just looking for times. I didn't hear times. I heard 3x minus 1. So, yeah. So 3 parentheses, x minus 1 close parentheses, right? Okay, if that's not clear as far as that being the LCD, what you want to do, go on YouTube and do a search for how to find the LCD of equations. Now, numbers, I have a few explanations that are simple. Once we start getting into these binomials and things of this nature, it can be a little bit dicey. And I know how to do it. I don't really know how to articulate all the little nuances. So if you're not confident in your ability to find LCDs of rational expressions, search it on YouTube and Google. Okay. Okay. So what's the LCD? We said 3 times x minus 1. So if we were to multiply the left and the right by that, give me a color. I'll do that. That's fine. So if we said this times 3x minus 1, I am not liking that. Hang on. No. It's my pen is acting up, and I don't know how to get it to stop doing that. Well, it's a new pen, and so I don't know. And let's go here. So we said 3 times x minus 1, right? So if we distribute, and then we got to do it over here as well, 3 times x minus 1. Now the right-hand side isn't too bad, but on the left we have to distribute, so we're going to do it twice. When we say the LCD times that first one, what happens? When we say the purple LCD times that first term, what happens? What do we have on top and bottom? Yeah, the 3's cancel, right? The 3's cancel. In the second term, when we multiply by the LCD, what happens?
You got 2x.
It's the same kind of thing. What's going to cancel? X minus 1 is going to cancel. Let's look at it. Oh, and then also, we have to exclude any x that makes the denominator 0. What value of x makes the denominator 0 in this case? 1, right? So, right off the rip, x cannot be equal to 1. All right? So we got to be clear about that. So the LCD is 3 times x minus 1. So 1, yeah, so we set 1. 1 can't be one of our solutions. Now, when we multiply the left and the right by the LCD, we get this. You see in the first one, the 3's cancel. In the second one, the x minus 1's cancel. Those are all our cancellations. So then we're going to FOIL the first two. So you see the FOIL there. Combine like terms and there. Okay? So I know it's a little fast. Again, you want to work it and make sure that you can get to these conclusions on your own. Ultimately, eventually, we'll get to 1 equals 7x, and then x is going to be equal to 1 over 7. All right? Notice, so we confirmed that x is not equal to 1. Our claim is that x equals to 1 by 7. So then how can we check this result? Pardon? Yeah, plug it into the original. All right? Let's look at a demo on doing that task. Now, I'm going to do this in the calculator. This is my favorite way to plug numbers in. I'm going to use my graphing calculator. I have a virtual one here, thanks to some gentlemen at, I think it's Chemtech. I don't know. I forget the school. It's there. They did it. It's been working. I've been using this for years. I'm like, okay, it works. So I let it be. So I want to plug this into the original. So I'm going to go to my y equals, and I'm going to type in the original. When I plug in 1 over 7 into the left, what should it spit out for the right? Yeah, 1 over 7. See, if I plug in 1 over 7 on the left, then the right side is equal to x, so then the answer should be 1 over 7. So now the first term, the top is 3x minus 1 divided by 3. Then we're going to say minus, the top is 2x divided by parentheses x minus 1. Now, proper use of the parentheses take practice here. That was a tongue twister. Proper use of the parentheses takes practice. Peter Piper picked a peck of pickled peppers. Just being silly because it's a tongue twister. But on a serious note, parentheses is not trivial here. I think I typed it in properly, so I'm going to accept it. I'm going to go to variables, y variables. I'm hitting 1 and 1. I'm going to plug in my result of 1 over 7. Again, what result are we anticipating? I'm going to hit math as a fraction. We got our result. What number did we say should not work? 1. So I'm going to hit second enter. When I hit 1, what kind of result should I get? Undefined, right? Does not exist. Can't divide by 0. Makes sense, right? Okay, just confirming some of our results. All right. So the proposed solution meets the requirement that x is not equal to 1 and does not cause any denominator to be 0. So we plugged it into the original and it checked out. Okay. Questions, comments, or concerns before I go forward? All right, let's look at another one. What's the time? That clock isn't right. There's the correct time. Okay, I'm good. Okay. What's the LCD here? Okay. Let's take 5 minutes. Take 5 minutes. See if you can solve this one. See if you can solve this one in 5 minutes. Any brave soul feel like they can come to the front and walk us through it? The book? All right. I'm going to work while you all work. So I'm going to get a copy of the original. I just want this guy. I'll take that. That's fine. That's fine. We'll drop that right. Come on. Right there is fine. Why are you behaving this way? So, ladies, I am still listening to you all. So, in the back, all the chatter is like, I'm just listening, trying not to acknowledge it. But it's uber distracting. And that's not working either. I'm going to try one more time. You don't want to work? Yeah, see, now I don't hear it. That's much better. I'll take this and I'll edit here. Thank you. All right. And then we're there, and we're going to take a copy of this. So here. Let's copy. We're going to paste it here. All right. And this. All right, so let's see. Can you all walk me through what's the first step? Distribute what? What value can x not be equal to here? 2, right? Because 2 makes the 0 in the denominator, so keep in mind that x cannot be equal to 2. What's the LCD? X minus 2, okay. So here's the original x minus 2, x equals, we got an x minus 2, 2 plus 2, right? So I'll do orange style. So we're going to multiply the left and the right by the LCD. So we're going to say this times the LCD and this times the LCD. Okay? When we multiply by the LCD on the left, what happens with those? You get x. They cancel, right? Then on the right, what are we doing? We have to distribute, right? Okay. So the first term, what happens? They cancel, so that's going to cancel. And we'll finish with what? Just 2? And then plus what? Okay. So we got rid of our fractions. One equation, one unknown we can solve. What's next? Distribute. So then we get this is what? 2x minus 4. Then what? Okay, we can combine like terms. I'm going to isolate the variable. I'm going to move the variable to the right. I guess it's easier to move it to the left. I'm going to go ahead and subtract 2x on both sides, right? So we get a negative x, negative 2. So then x equals 2. But then what do we say in the beginning? So then what's the solution here? Yeah, undefined, the empty set, no solution. These all say the same thing. Which one? Oh, I subtracted 2x. So I said 1x minus 2x. I got negative x. Yeah. So yeah, we said 2 doesn't work in the original, but when we crunch the number, we only get 2. So now, if we didn't identify the domain in the beginning, that 2 at the bottom here, this is what I call the right-wrong answer. Algebraically, it's right, but it's actually outside of our domain. So when you check it in the original, it doesn't work. So then it's actually wrong. So you just have to check. Okay? But we identified our domain in the beginning, so we were good to go there. So we got no solution. So no real number should work here. Let's see. We did that. So this. But however, it's restricted. If x is 2, it causes 0 in the denominator. So the solution set is the empty set. Okay. Questions, comments, or concerns before I go forward? Going once, going twice. Hold your peas and rice. Okay. I kind of want to get this one started. I don't want to go all the way in depth on it. Can you identify the LCD for me? Okay, so the right one is correct. What does it factor into? So we have x squared minus 2x. What do they have in common? So we could factor out an x from both of them. So I agree that the LCD is on the right. We're going to say x times x minus 2, right? So now we say the left by the LCD, we're going to get some cancellation going. We say the right by the LCD, we're going to get some cancellation going. What values of x can this not be equal to? 2. Okay, so if we set the first one equal to 0, we get, there's the x equals 2. So if we set the second one equal to 0, what do we get? 0. What about the third one? The one on the far right. Okay. Let's do this then. So if I said x squared minus 2x equal to 0, if we solve for x, what can we do? We can factor out the x. So we have x times x minus 2 equals 0. What values of x makes that 0? So we have x times x minus 2. Remember the zero factor property. When things multiply to give us 0, then either the first thing is equal to 0 or the second thing is equal to 0. Well, no. I'm saying you got to set each one equal to 0 and solve. So what kind of 0 do we get from the first one? 0. And what 0 do we get from the second one? 2. So that x squared minus 2x, we're saying that x can't be 0 and 2, but we've already identified those. So we already had the solution. Okay. Because I know that kind of gives students a hard time. Let's see. So now, long story short, x cannot be 0, x cannot be 2. X is not equal to 0 or 2. And I know this is a lot. You're just trying to keep up with what I'm doing. You really kind of got to take the original, take a few pointers here or there, and then you got to work it yourself. If you try to follow what I'm doing, you're going to get brain fog, and it's going to be like super dense in your head. If you take pointers here and there, just little tips and tricks, and if you take the original and work it yourself, you have a much better time, and it'll sink in a lot better than trying to listen to me. I'm just giving you pointers, you know. Okay, so now we got the x can't be 0, x can't be 2. We've identified our LCD, so now we just proceed the same way we did last time. We say the left and the right by the LCD. We do our cancellations. We expand, isolate our variable, that kind of jazz, right? So we have the original. We multiply the left and the right by the LCD. You see the cancellations, right? Okay. So here's this cancellation. Here's this one, and this is canceled by that on the right. So when you do it, you'll see it. So right now, we're just trying to touch on the key points, but you got to take some time to practice. All right, let's keep going. We're still working. Should be still working the same one. Okay. So now, when we do our cancellations, we should get to this point. Yes. Yep. Yeah. Okay. So now we've done all our cancellations. We've gotten to this point. Now we just want to do any kind of distributing, expanding, things of that nature. Isolate the variable, and then solve. All right. So we get what? 3x squared, 2x, and then combine like terms. Right. So now, if we have 3x squared plus 3x equals 0, if we wanted to solve for x, what would you do? What would you divide by? Okay, if you actually combine what you two said. Okay, you want to combine what you two said. Yeah, we want to do something with the 3x. We don't want to divide by 3x because then we're going to lose one of our solutions. If we divide by 3x, then we're going to lose one of our answers. So instead of dividing by 3x, we want to factor out the 3x, the GCF. So that's why I say combine, because you said factor, and then you said 3x. So if you want to factor out 3x in both of them, so then when we do that, we get what? X plus what? X plus 1, right? So then we'll have 3x times x plus 1 right there. So now if we had divided by 3x, which I'm glad that you said, because that's how students usually like to do with their. Students typically like to divide, but then you're going to lose. You would lose that 3x, and you would only have x plus 1. You would only have one of the correct solutions, and then you'd be led astray. So instead of divide there, again, we wanted to factor, so we don't lose any of our solutions. Okay? So now from this point, what values of x will make it 0? So for the you got the second one. We said x plus 1 equal to 0 and solve. We do the same thing with the previous part. 3x equal to 0, so then x has to be 0, right? Because if you divide both sides by 3, now you would divide. So you divide by 3, you get x equals 0. Okay, so we're gonna get some practice. We got to get some practice because again, you can't just listen to this stuff. You don't really learn by listening. So there are 3 modes of learning, at least that I'm aware of right now. There might be more. You can watch somebody do something. You can, well, I'm thinking training that I've done. But in some training that I've done, we can watch someone do it. We can have someone use the technique on us, or we can do it ourselves. Now, I know in this atmosphere it's going to be a little different. Like you can watch me do this stuff. You can listen or have somebody explain it to you, or you can do it yourself. You know, so that's not all the way there. But the whole point is, listen to me do it is one level. The real way you're going to get it, you have to do it yourself. But now, from here, we get that x is 0 or x is negative 1. Do we have any restrictions from the beginning? X can't be 0, x can't be 2. So then, so the answer is only negative 1, right? So 0 is an extraneous solution. Okay, so when we try to plug 0 into the original, it's not going to work. The only one that works is negative 1. Again, at that point, if we put both of those answers without checking, that's called the right-wrong answer. Algebraically, it's correct, but then one of those solutions is outside our domain, so we always want to check. Again, when we get on the exam and we don't check our work, what we're saying is we've been in school all this time, I've been studying, I've been working all this hard. This answer may or may not be right, but I'm going to leave it to chance. Chance favors the prepared mind. If you want to boost the odds of success in your favor, check your work. That's what made me fall in love with mathematics. I was able to check it. Once I finished it, I would go back and check. I would triple check, you know, and then I drastically increased my chance of success tenfold. Not that I'm got anything figured out or anything. I'm just saying just for this atmosphere. Okay. We need to practice. We need to get some practice. All right. Give this one a go. I'm going to set a timer for 10 minutes and just give it a go. See what you can do. Okay? 10 minutes is kind of a lot, though. Up top was the previous example. So this is a new example, and example 2b. What's the LCD? Okay, I hear that x squared minus 1 is the LCD, but what does that factor into? Okay, so yeah, that's difference of squares. That's the first binomial. So then the LCD ends up being x minus 1 times x plus 1. Is that not clear for anybody? Because now you see if we multiply, we pretty much took one factor from each denominator. We got the x minus 1, we got the x plus 1. Once we had both of those, each factor was accounted for. Okay? So now you can take this and do the same technique we were doing before. I want to say the left and the right by the LCD. We multiply the left by the LCD, we're going to have to distribute, and we're going to get some cancellations. What are our restrictions? What can x not be equal to here? Is this okay? Because 1 will make the first one 0, -1 makes the second one 0, and both of them make the third one 0. Hey Siri, set a timer for 10 minutes.
Your timer is set for 10 minutes.
Give me, for the audience here, give me, yeah, the word. Yeah, that's what I needed. Thank you. Wait, why'd you say cupcake? What was it that I was going to say? Yeah, that's it. Because I wasn't sure if you were talking about the word or the cursor. Because sometimes I do the same thing for the cursor. That's why I was trying to get you to say it. But yeah, I needed the word. So we'll do cupcake. So if my audience at home is listening, the word that I'm looking for is cupcake. So that was the one suggested by the audience. We're going to take a 10-minute hiatus. I think my timer is running. So keep that in mind. So you might want to just fast forward by 10 minutes or whatever timestamp you're at right now. Okay, so I think my timer should be running. So let's just take a little bit of time. I want you all to give this a go, okay? Because you got to practice it. And these rational equations, I know I kind of move fast and talk fast, so you definitely want to just make sure that you can do it. Okay? But so far they've all been the same. So what happens when you multiply the LCD? Right. The x minus 1 cancels, and we're left with the x plus 1. What about here? Same thing. X plus 1 is going to cancel. This is going to be up. And then this one, they're both of them cancel, right? That's going to cancel both of them, right? But then once you do that, yeah, they multiplied. There it is. Once you do those cancellations, you'll be here. So you multiply and do that cancellation, which is here. So this one you should know what to do. What would you do next? Distribute. Combine like terms set to 0. Right? Squared x to x 4 at 8 is positive 4. And that's these two cancel. Now, if this is equal to 0, what do these two have in common? What are we going to do with that 4? Okay, yeah, actually in this case, because we're not factoring out the variable, you could divide both of these by -4 or 4. But in that last one, if you've done that, the x would have canceled and you would have missed solution. So you can factor out the 4 and you'll still work. Yeah. I know that's a little bit. A lot of these things are very subtle, and the only way you're going to catch the subtleties. A lot of these are very subtle, but the only way you're going to catch the subtleties is you got to work it, and it'll start to reveal itself. But if I tell you, this is kind of information overload. Again, this stuff is not complicated. It's not difficult. It's just information overload. So that's typically what goes on with this course. Okay, so the only way you can kind of mitigate that experience is you got to be doing reps at home. You have to.
So after that, you just factor it.
Yeah, you want to factor out. What do they have in common? What are we going to factor out? You can do a 4 or you can do -4. It should work. So they divided by -4. They got x squared minus 1. What does this factor into? Okay, so this factors into x plus 1, x minus 1. So then x equals, but then didn't we have some restrictions in the beginning? So then no solution. No, yeah, same thing. Yeah. So empty set, no solution, undefined, not a real number. No real number is going to work. Okay? So hopefully you were on your way here. Let's see what else do we have. going to move forward. Okay, work rate problem. Because if we put -1 in the original, what will happen? We get what where? We'll get a 0 in the denominator. So those are the two extraneous solutions we had to throw out in the beginning. All right, I'm going to move forward. So then work rate problems. These, the wording of these always kind of throws me for a loop. I need to stop saying that because all I'm doing is perpetuating that stigma. But I have my own kind of little way that I work these. I haven't fine-tuned it like I've done other things, but let's see it in action. So work rate problems. These are problem solving. If a job can be done in T units of time, then the rate of work is R, which is going to be 1 per T of the job per unit time, right? The amount of work completed, A, is found by multiplying blah, blah, blah. Now, the way I kind of approach these, I think of them like distance problems. It's like distance equals rate times time, but instead of using the distance, I'm going to use A for amount of work done. So to complete one task, we're going to say rate times time. So now, but in my mind, I'm thinking distance problems, like D equals RT. And typically that setup is enough to kind of synthesize it properly. So let's see it in action, right? Let's see it in action. Okay. We're going to be there, and we would like a blank page. Yes, we want to paste. Looks good. Okay. So now, this example, it says one printer can do a job twice as fast as another. Working together, both printers can do the job in 2 hours. How long will it take each printer working alone to do the job? Okay. So what I'm going to do, we're going to make a table, right? I'm going to base this on distance equals rate times time, but I'm going to, instead of using distance, I'm going to change that to amount of work done, right? So we have, give me color. Blue, all right. So we have printer 1, right? And then we have printer 2. We're going to say rate times time equals amount or work done, something like that. I'm going to make a quick table. So I like the table construction. That seems like it simplifies the information or organizes it a lot more coherently for people. I'm going to go like this. And then like this. Move this up. And then like this. All right. So now, again, I'm building this on the concept of distance equals rate times time, but instead of distance, I'm going to put amount of work done. Now let's put amount of work done. Okay. So now let's go back to the text. It says one printer can do a job twice as fast as another, right? So say the faster printer is the first one. So say the rate of printer 2 was R, right? So then what can you tell me about the rate of the first printer? 2R, right? It's twice as fast, so the rate is 2 times that. Hopefully I'm not going to mix this up like I usually do. It says if the printers work together, the job would take 2 hours, but we don't know how long it takes. So we want to know if they work alone, how long it would take them, right? Now, say printer 1, it takes them X what? What are the units? Hours. Say it takes printer 1 X hours to do the job, right? Let me think about this for a moment. Give me a moment. Give me a moment. Okay, so now, say printer 1 is twice as fast as printer 2. Hopefully I'm thinking of this properly and I'm not mixing it up. Give me a second. Wait. So now, if it takes printer 1 X hours, right? To do one task. Yeah, that's time. I'm just trying to, hold on, I'm just trying to think of, make sure I have my labels properly. I'm trying to do it without looking at the result, is what I'm trying to do. The rate times time, yeah, I know I'm going to multiply those. I'm going to glance at it. Give me a moment. I don't want to keep doing that. It's right. The rate, half that. 1 by x. Yeah. Okay. So this is where I always kind of confuse myself. So let's do it like this. So if it takes the first printer X hours, right? Takes the first printer X hours to do one job, right? So then the person's rate, if you think distance equals rate times time, that's my 10-minute timer. So then his rate is going to be 1 by x. I can agree with that, right? So that means the second printer, if this one is twice as fast as the other one, then how long will it? If it takes this one x hours, how long will it take the second one to do the job? 2x, right? It's going to take them twice as long, right? To do one job. So then, what's his rate? 1/2x. That's what I was trying to straighten out. You see how initially because I was doing it based on rate, it was leading us astray a bit. Do you see what I mean? Like initially I had r and then 2r, and you can do it from that angle, but that doesn't really work for me. So again, now I think this looks familiar. This looks right. Notice first we did the time, right? It takes the first printer x hours, however long that is, to do one task. Give me a color. I think I heard orange. Give me an interesting random object. These aren't interesting. Balloon. Okay, I heard cow. So I'm going to fuse with all what you just said. I'm not going to do colors. I'm just going to really quickly, I just want something quick. Like this. The cow's head is like this. It's like this, right? Like that. And then, wait. And then that. Cow was on something, I don't know. And then like this, okay? And then, but I heard, we said what, balloons, right? So just real quick, just want to get some quick balloons. Like this, right? Balloons. And then I heard a star, and he's floating up to a star. So then what I'm going to do to fuse all of these, just really quickly, I'm just making it interesting. I said interesting. Oh, no, undo. And I didn't realize I got that. So what I'm going to do really quickly, take that. I want to take the cow. Nope. I think I picked up a pen, so we can shrink that down. The cow is, he's holding the balloon, so he's floating up to the stars. And what I'm going to do really quickly for my stars, I want to copy. I'm going to just paste a couple real quick like that, like that. Some of them are close, but then paste real quick. I'm almost done. Just like that. Some of them are a little bit smaller. Copy, paste, paste. And let's do one more paste, and then I'm going to do this, paste. I'm going to make some even smaller. Copy and paste. Really quick, I'm almost done. Paste, and then what we're going to do is take all of this, and we're going to shrink it down to size. So, and then you know what? I'm just going to go ahead and copy that and paste that a couple of times. So now we got some stars. Just for being interesting, yeah. Copy and paste. Oh no. Okay, that's fine. And I want it like right. That's fine. And just filling that in. That's fine. And so then I want to take all of this. It's a cursor, yeah. I want to move that out of the way. All I did was copy and paste a whole bunch of times over and over and over. Okay, so and the cow is floating up there. And shrink it down. I had nothing better to do with my time. Okay, so that's the image I wanted to do. And you know what? Just because, let's copy and paste. All right, so like that. And then you know what? I'm just going to move some of this like here. That's fine. And then just a little bit more. I want to copy, paste. All right, and that's good. Okay, that's good. And then just a little bit closer. And then the copy and paste. All right, that's good. That looks much better. All right. And so that's our cursor for today. All right. That's fine. But you saw how it was constructed. Okay. So that's our cursor. Okay, so now the whole reason for all that. Just to kind of break up the energy and wake us up. Now, but you can see it though, right? That's the whole. See, you're smiling, you're laughing again. That's all I was trying to get out of you. Okay, so now you saw the original construction, how the R, you can do it based on the rate, but I knew that was confusing. I was like, wait a minute. That's why I kind of paused for a second. So now, if the first printer does it in X hours, and it's twice as fast, that means the second printer is going to take twice as long to finish, right? But so in order for printer 1 to do one job, that means his rate to do one job is going to be 1 per x, right? Miles per hour, yeah, unit per time. The second one is going to be 1 over 2x. Now, that's the starting point. Let's go back. So now one printer can do a job twice as fast as another. Working together, both printers can do the job in 2 hours. So then we say x plus 2x should equal 2. Is that right? No. 2 hours. How long would it take each printer working alone to do the job? So we need to solve for x. Is it x plus 2x equals 2? I think so. Yeah, I think so. Well, I'm trying to do it without looking because, you know, if I look, then I'm doing it based on what I see. But I want to, because the reason I'm trying my best to do it without looking, because that's kind of how it's going to be. I'm trying to simulate what it would be on an exam. You know what I mean? If they work together, I think it's x plus 2x to give us 2. I think that's fine. We got that. That's fine. We got that same stuff. That's fine. Parts of the job accomplished. Oh, okay. So that's how, okay, so I did my chart a little bit different. So working alone, so let's kind of synthesize what they have. So look, now the faster printer working by itself. Okay, so you got to take what we did in our chart and apply it to this one. Our chart was if they were each working by themselves. This chart is if they're working together. This is what I was trying to straighten out in my mind, right? So in theirs, now if they work together, the faster printer is going to do, the total time they have is 2 hours. The faster printer's rate is 1 per x. Notice we got that one from our chart. So then the part of the job accomplished is going to be 2 times 1 over x. We get this result. The slower printer still has 2 hours to do the job. We got this rate from our chart. So these are 2 different charts going on that you have to be aware of. It's very subtle. It looks similar. Again, the chart that I had earlier, that one is each printer working by itself. So printer 1 does a job in x hours. So to do one job, that printer's rate is going to be 1 by x. Printers 2 is going to take twice as long, so the time is twice as long. To do one job was 1 over 2x. Now you see that 1 over x and that 1 over 2x. This chart is saying if they work together. This chart is if they work together. So if they work together, they both have 2 hours to do the job. The rate of printer 1 is going to be 1 by x, and the amount of work done by this is going to be this times this to give us this. Printer 2 still has 2 hours. This is printer 2's rate we got from our chart. Then 2 times this gives us 1 over x. Then it should be this plus this to give us 1. Let me see. That plus that to give us 1 whole job. So the part of the work done by the faster printer plus the part of the work done by the slower printer in order to do one whole job. So this is why I was kind of pausing, because I knew that there was like multiple lines of thought on this example. And it's just these work done problems. This is the only one that really gives me a little bit of a hard time. But ultimately I'm able to do it to a degree. Again, this is why I don't mind doing open notes for you all. Everything is kind of jammed and rushed. So I don't mind the open notes when we take an exam. Okay? If this were to pop up, just have to do the best that you can. But only way you're going to get comfortable with it, you got to get repetition in. Do it once to get it correct. Do it again, and then that's where the My Math Lab comes in. It'll give you alternate versions of the same question with different numbers. Okay? So now that's a mouthful. That one, you know, it is what it is. You have to do the best that you can. Do your best, forget the rest, don't stress, and be blessed. So then, but from this point, once we have one equation, one unknown, at that point we're ready to solve. So again, the amount of work done by the faster printer plus the amount of work done by the slower printer equals one whole job. Okay? From there, I think you all can take it. It's the same thing as before. Okay? Hopefully we can get another one of those. I don't think we get another one in these examples. Yeah, and it's just, and that one, let me see, there's an explanation. So you know how to follow the rest of it. I want you to see this though. So it says, example 3 can also be solved by using the fact that the sum of the rates of the individual printers is equal to their rate working together. Since the printers can complete the job together in 2 hours, their combined rate is going to be half of the job per hour. So, you know, you can, long story short, you can solve the same equation based on rates. We did it based on work done, amount of work accomplished. I know that was a bit much. You just have to do the best that you can. I will say this as a disclaimer. If you can handle my study guide, if you're comfortable with everything on my study guide, you should be okay for my exam. I know the first exam is what it is. I don't plan on doing the same thing from the first one. Okay, so again, if you can handle my study guide and all that, you should be okay for the exam. 13. What's the time? Let's keep moving. We're just shy of half. We're just about halfway. So we got a little bit of time. Let me keep moving. I think this is based on rate. So the rate, yeah, and it equals a half. Okay, so let's keep moving. So now, if you're not comfortable with that, keep in mind you can actually get through this course and not get that, and you'll be fine. So if that's a bit much, you can just kind of skip over it and just try to maximize other concepts. Okay? But it just takes time and repetition. You just have to do a bunch of reps. Now, let's just dump all that for right now mentally. Just dump it, put it, compartmentalize it, come back to it later. So now, let's move on to the next concept. We have this one called the power property. If P and Q are algebraic expressions, then every solution of the equation P equals Q is also a solution of the equation P to the power of n equal Q to the power of n. So these are typos. These are supposed to be P to the n equals Q to the n for any positive integer n. Okay. Be careful when using the power property. It does not say that the equations P equals Q and P equals P to the n, Q to the n are equivalent. It says only that each solution of the original is also a solution of the new. We might have some extraneous solutions. Let's see what's going on. Radicals. Let's see. Isolate the radical on one side. Then use the power property. So use the appropriate power to get rid of the radical. Solve the resulting equation. Check each proposed solution in the original equation. If a radical persists, isolate the radical again and do it over again. Okay? All right. I'm going to do this one, and then I'm going to kind of breeze through the next one. I would like a blank page, though. Okay, let's bookmark this. We need... Let's copy. Right here, I'm going to paste. And I want to clear the page. That's fine. And the original, didn't want to see the solution. Okay, we're here. So I'll work this one, and then I'm going to go a little bit faster if we get another one of these. So I know it's a bit much. Again, you just have to do the best that you can. So here's a copy of the original. All right. Now let's see this in action. Oh, no. Okay. Square root. Oh, so now we're solving an equation involving square root. First thing we want to do is isolate the radical. Get the radical by itself, right? Give me a color. What? I think I heard pink. Hopefully it's not too bright. So isolate the radical. I'm going to add the square root to both sides. If I do that, I get the following. 15 minus 2x equal to x. If I add it to the right, I just reverse it. Does that make sense? Okay. To get rid of the square root, we raise both sides to the power of what? 2. So to the power of 2, power of 2. These are going to cancel each other. So then we get this. X squared. Set it to 0. So I'm going to move everything to the right. We get x squared. I'm going to say plus 2x minus 15 equals 0. If you move everything to the right, you'll get this exact same thing. Okay? If you move it to the right, you will get this. Subtract and add, yeah. So now, if we factor this, we were looking for two numbers that multiply to give us what? Negative 15 and add to give us... Okay, so 5 and negative 3. So then x equals 3 and negative 5. Okay, so to identify the extraneous solutions in the beginning. So we cannot take the square root of what kind of number? We can't take the square root of... Negative. We can't take the square root of a negative, right? That's just a property. Even roots. You can't take the square root of negative numbers. So whenever you see square root, now if it's like cube root, that's different. Fourth root is the same as square root. So whenever you have an even root, it needs the radicand needs to be non-negative. So long story short, what I mean by that is that this 15 minus 2x, the radicand needs to be greater than or equal to 0. So then if we solve, divide, so then x has to be less than or equal to 15 over 2, which is what? 7.5, right? So if x is anything strictly bigger than 7.5, then it's going to be extraneous because it should make the original not real. So then let's see. Do we have an x that's larger than 7.5? So all our x's are less than 7.5. They should work in the original. So let's check them in the original. So then I'm going to go, I'm watching the clock. We got right at 20 minutes. So I'm going to go to y equals, and I'm going to type in the original. I'm going to say x minus the square root 15 minus 2x, close parentheses. Okay. Let's see. Let's go to variables, y variables. Number 1. I hit the wrong thing. Let's go to variables, y variables, y1. Now, okay, so when we plug in 3, on the left, in the original, what result should we get? 0, right? Let's see. So if we plug in 3, what happens? 0. Let's try negative 5 just to make sure. Negative 5. Okay, so did we get our 0?
Yes.
When we plug in negative 5? No, right? Let's check it. What's a negative 2 times negative 5? 10. What's 15 plus 10? What's the square root of 25? What's negative 5 minus 5? Negative 10. So that means if I had walked away from this, if I had stopped there and I didn't check it, and if you had caught that mistake, you actually could have got extra credit. If you walk away from this on an exam and you leave it at this, like the way it is now, you would lose credit. This is wrong. Because negative 5 is an extraneous solution. The only thing that worked in the original is this one. You got to check it. Let's see. So yeah, the negative 5 didn't work. So the only thing that worked in the original was the 3. Let's see. Okay, this one, I'm going to kind of walk you through this one. So notice we got 2 square roots. My claim is that you still do the same thing. Do the same thing. First, let's isolate a radical. So we're going to move one to the other side. We're going to add that second one. So we're going to get, we got one radical by itself. Hopefully I still have my cursor. That was an extravagant cursor. Come on. I know that you're there. You saw it? Oh, good eye. I did not see that. I want to copy this one right here. Thanks. Okay. Oh, so now you do the same thing we did in the last one. Isolate a radical, so we're going to add this one to both sides. We're going to add the second one to both sides, and we get the following. We're going to get rid of this. And actually, let me, no good. I can't get back to where I was. Okay, I got to undo. Come on. Oh, you messing up on me? What's good? Really? All right. Might have to close it. All right. I'm going to just delete that for now. Ooh. It's bugging. Okay, there we go. And then we are here. We left off. Yeah, go. Okay, it's there. Okay, so let's copy this. Okay. Yeah. So we added the square root to both sides, and that put us here. So then we do the same thing. We're going to square both sides. Now here, the radical is going to cancel. But then here, we got a FOIL. So something times itself. We have the FOIL on the right. It's a little bit bulky, but that's what you have to do. It is a little bit bulky, but that's what you have to do. All right? So then when we FOIL, we eventually get here. So then at this point, now we have one radical. So then we're going to isolate the radical and run it back. So isolate the radical, combine like terms. Eventually you get here. Square both sides. And then we are here. And then set to 0 and factor and quadratic and all that kind of jazz. We should have found the extraneous solutions off the rip. We get x equals 3 or x equals -1. We just need to check these in the original. We can check them in the original. So I think that they both work in the original, so we're okay. Okay. We got a good amount of, we got a little bit of time. Let me pause for a moment. I feel like there should be questions, comments. I know everybody's fading. I'm going to finish out this section, and then we're going to call it a day. Yeah, I know. We're going to finish out this section. We're going to call it a day. I'm going to leave a lot of these as exercises, so you want to go through these and make sure that you can do them. Okay? Remember to isolate the remember to isolate a radical in step 1. It will be incorrect to square each term individually as the first step in example 5. Okay? So isolate, square, and all that kind of jazz. Now here, we got the cube root. How are we going to get rid of cube root? What's the first step here? Isolate the radical. So we can add that second one to both sides. We're going to have cube root equals cube root. How do we get rid of the cube root? Cube both sides. So we're going to say both sides to the power of 3. What's going to happen? The radicals are going to cancel. Then we're going to have 4x squared minus 4x plus 1 equals x. Let's get to that point. We see it right here. Then what are we going to do? Set it to 0. And then we're going to factor. Okay, I know that was a little intense. So I just wanted you to see. We still isolated the radical. Then we did the same thing essentially. So we follow the dominoes, follow the cubes. We got just shy of 20 minutes, maybe more like 15. I want to kind of finish this. So then we factor. From there, you know what to do. You know to check in the original and make sure that it works. Say you had something like this. You have x to the power of 3/5 equals 27. What does the exponent of 3 over 5 mean? Let's go like this, right? So x to the power of 3 over 5 means, there's two ways you can look at it. The 5 is what? It's the denominator, it's the index of the radical, right? So one way you can look at it is the 5th root of x cubed, or you can say the 5th root of x quantity cubed. Okay, as long as the denominator is odd, this is fine. If the denominator is even, one of these becomes absolute value. We'll talk about that as it pops up. It's a little bit different when the denominator is even. Yes, but the denominator is the index of the radical. So now, if we have x to the power of 3 over 5, if that were square root of x, what would you do to both sides? You would square both sides, right? Can you write the square root of x as a rational exponent? The square root of x is the same as x to what power? X to the 1/2, because the index of the radical is the denominator of the exponent, right? So what I mean by that, the square root of x is the same as x to the power of 1/2, right? Now, we said if we wanted to get rid of the square root, we would do what to both sides? Square both sides, right? Notice, 2 is what? The what? Reciprocal of the 1/2. So what do you think we need to do with this x to the power of 3/5? To the power of the reciprocal. So we're going to say both sides to the power of 5/3. What does 5/3 mean? Well, that means the cube root of 27, maybe take that answer to the power of 5. Does that make sense? If you say 3/5 to the power of 5/3, what do we do with those numbers over here? They're going to cancel because we say a power to another power, we multiply those fractions. They're going to go to 1. They're going to become zen. I know it's a lot. I'm just showing you. You got to kind of do a little bit of digging to confirm. and lock it in. Again, my students in the past, once they got on my math lab, I have students that would, just to get the reps in, they would, even though they got it right, they would work each question at least 3 times. And then by the time they got on my exams, they were blowing it out of the water. They were just like, oh, this is the exact same as the homework. I was like, yeah, that's what I've been trying to get people to see. And they got a perfect score on my course. So they just got, I know, and that's a time, I know the time factor. Because of the time factor, that's why I do open notes. But the drawback is the students tend to kind of shirk it off until right before the exam. They don't study. I know everybody doesn't, but they think that, oh, I have my notes, I should be able to figure it out. You're not going to be able to. You have to be working all the while. Team up. I know there's at least 1 or 2 students in the class now that has at least seen this before. So, I know that I can be kind of intense, so that's why it's important that you all work together or get a tutor or, you got to get multiple angles, multiple perspectives. Okay, let's keep moving. Cube root of 27, is that a perfect power of 3? What times what times what? This is 27. 3. So the cube root of 27, I'm watching the clock. Got to wrap up. It's going to be 3 to the power of 5. 3 times 3 is 9. 9 times 9 is 9 times 9 is, so that's power of 4. 81 times 3, whatever that is, 243, right? 243. Okay, 243. So just look at it. I just wanted to expose you to it, just show you some ideas so you at least know what you're looking for. We get what we're looking for, and if you're not aware of certain things, you're not even looking for them, you're going to miss it. But at least if you're aware, it's like, wait a minute, what did he say? Let me go and look for it. Then you'll find it. So we get what we're looking for. So, let's just forget that. Okay, so that's a little bit, it's going to take some practice. Okay. I want to show you this really quickly. I'm watching the clock. That, like right at 5 minutes. I want you to see this. So now, you see where here we knew, we needed to do 27 to the power of 5/3, right? So watch this. We can say 27 to the power of 5/3, just so that you know that you can actually do this in the calculator. Again, this technology is really just an extension of our natural abilities. All the things that this technology can do is really just a personification of what we naturally can do. It's just that we don't ever take the time to develop our natural abilities and talents because of, we're distracted a lot of times, so we never take the time. But the people that are great, they taking the time to figure themselves out. And I had a professor at Morehouse. You can rattle off numbers, be like 273 times 415, and he'll spit out the answer fast, and you can type it in your calculator. That's a whole field in mathematics. I think it's called like number theory or something like that. But he had all these, he knew how to crunch numbers like literally in an instant, way faster than the calculator. If you go on YouTube and do a YouTube search for a human calculator, they have so many funky little tips and tricks and ways of crunching numbers and just little interesting little math things, things that help. So just do a YouTube search for human calculator. Okay, we're right at about 10 slides. I'm really trying to wrap it up. I'm going to leave this one as an exercise. Notice, if we have something on the left to the power of 2/3, if I wanted to get rid of that 2/3, what would I raise both sides to the power of? 3/2. I would say both sides to the power of 3/2. So I just want you to be aware of that. You can follow the breadcrumbs from there. Notice, it's plus or minus because the denominator, when we say to the power of 3/2, it's like taking the square root. So when the denominator is even, we got to include plus or minus. That comes out of the whole square root discussion. Okay. If the denominator is odd, you don't need the plus or minus. There's more to that discussion, but that's what we need for right now. Okay, so I'll let you kind of explore that for a minute or on your own. So a quadratic, an equation is said to be in quadratic if it can be written in the form of a something squared plus b times that same something plus c equals 0. Quadratic form, the standard form of a quadratic, ax squared plus bx plus c. Well, instead of x, we're going to have many expressions. So if you have a times some expression squared plus b times that same expression plus c equal to 0, that's quadratic in form. And then we can apply like some techniques we've been using before. Okay, so notice, what do you think is the u? Yes, so what's the u in this case? A lot of times the u is right in the middle, right? So in this case, we're going to say let u be x plus 1 to the power of a third, right? So then we can rewrite the original in the following way. What does it become? U squared minus U minus 2 equals 0. You solve this. What's the solution here? What does this factor into? We got U and U plus and minus. What are the two numbers? 1 and 2, right? 1 and 2, right? So then U equals -1 or U equals +2, right? But then we say U, we see it there, so we got to plug it back. So that's a technique called U substitution. I'm going to write this, and you're going to have to look it up. This is a technique called U substitution. Substitution. I kind of struggle on my spelling. Okay, U substitution. So again, we were able to rewrite the original as a quadratic in form. And a lot of times the U is right here. It's right next to where the B would be. Okay, so just look at it. I'm giving you like a little bit of the highlights. You got to go and find and work out all the details. I'm going to leave the rest of it as an exercise. Okay, I'm going to leave that for you. What do you think is the U here? If I were to say U substitution, what do you think is the U here? So the U is going to be x to the -1. It's right there. Again, it's typically in the middle. Not all the time. I would say at least 80% of the questions we come across. I mean, this is just what I've noticed. When it's a quadratic in form, usually the U is right in the middle. It's not always, but that's a good place to start. Let me, I'm just trying to wrap up. I'm going to finish in the next 5 minutes. Can you rewrite this as a quadratic? 6U what? Squared plus U equals 2, right? So that from there you should be able to solve for U. Solve for U and then plug it back into the original. Okay, I'm going to leave the rest of it as an exercise. Okay, so you can do it. Let me see. We're almost there. So I'm going to leave these as exercises. So caution when using the substitution variable in solving equations that is quadratic in form. Do not forget the step that gives the solution in terms of the original variable. So once you solve for the U substitution, just be sure to go back and plug it back in and solve for the original variable. I know this is a mouthful. You'll see it when you start working examples. I'm going to move forward. What do you think is the U here? Let U be x squared, right? So let U be x squared. So again, this doesn't always work, but I noticed for these kind of questions, at least 80% of the time, the U is right in the middle. Now, sometimes it will be a little different, but, for right now, I'm going to leave the rest as an exercise. I'm going to leave that as an exercise, so we're out of time. I think it's the same one. You keep going. Eventually, you'll get here. Okay, you'll see it. Just work it. Oh, but then you got to check it in the original. You got to check each one, and then you'll find out what works. Okay. This is the second to last slide. So it says some equations that are quadratic in form are simple enough to avoid using the substitution technique. We can factor directly. I mean, yeah, if you feel confident in that, that's fine. When we start testing on this, it'll be multiple choice. So what I plan on doing, I'll give you probably 10 questions, and then you will still have to work it, and then you have to choose the correct answer. Okay. Let's see. I think that's it. Okay. Let me go ahead. So I'm going to send this to Box. The location, this is the winner. This is college algebra. Entire class into the notes. This is 1-6. I want all the pages. I'm sending it to Box. When this bar finishes loading, you'll get a copy of anything that you saw me write on the board. So you have your work cut out for you. What's a good idea? Be neat with your homework notebook. You still want to bring it. Go through the study guide. Go through the homework. Just be neat and organized. Again, if you're comfortable with my study guide, you should be okay for this exam. You should be. Exam will be Monday. Huh? Did y'all see a study guide? Okay, so I'm still working on resetting up the My Math Lab. Let me check Box really quickly. If I go to Box and I'm watching the clock, I want to close this out. Come on, close it out. I want to go back. This is you all. Let's look at the study guide. So I will load the PDF for the study guide. The study guide is actually loaded in the My Math Lab. I know it's not operational. So what I'm probably going to do for My Math Lab, I'm going to delete what's already there. And then I'm just going to create something and not link it to Moodle. And then I'm going to give you all the course ID. When I give you the course ID, you'll be able to get the 2 weeks of free access. Okay? So that's how we're going to have to work around to get that going, because just linking it to Moodle is just creating too much of a headache. Okay, any questions for everybody before we kind of part? So I know that was a lot. I know it's like, put your head down. You just got to rev yourself up, and be sure to go through this material. Be sure to team up with your classmates. Do the best you can on your own. Work together, and find a tutor and all that kind of jazz. Otherwise, we're going to end the session here. And from one beautiful mind to another, I will see you next time. All right. So I'm going to stop streaming.